Okay, so the notes here, let's call this solving a triangle. And the first example we already saw, whoa, the first example we saw was pretty basic. So we're going to skip over that one and get right to the more complex looking one. And that one they gave us a triangle. And it looked something like this. It said A, B, and C. Okay, very common, right? Have a C as your right angle. And they told us this piece up here was 62 degrees inside this little angle there. Okay, and they gave us this. And that was it. Okay, and for a right triangle to solve it, we have to find A, we have to find C, and we should find angle A. Okay, that would be solving the triangle. Solving the triangle means you have all the angles and all the sides identified. So obviously the little box here is 90 degrees, so you don't have to even write that. So we actually already have two angles in one side. So to get the third angle, we know that they always add up to 90 degrees, so or 180 degrees. So we can say angle A plus 62 plus 90, that's going to add up to 180 degrees. Adding 62 and 90, we get 152. That still adds up to 180. So I can subtract the 152 to both sides. And what I get for angle A is whatever 180 minus 152 is, which is 28. Okay, feel free to use a calculator in those kind of situations. All right, so 28 degrees, that would go inside here. Cool, we have all three angles. Now we got to find all three sides. So here's something that's going to be brand new for you guys. All right, so we have all three angles. Now we got to find all three sides. But usually in this kind of case, in the past month or so, they've given us two pieces. And to find a third piece, it's easy. Just use a Pythagorean theorem. And if you see a problem in your problem set at this point, if you have two pieces, whatever it's a hypotenuse or one of the side lengths, you can always use the Pythagorean theorem or the Pythagorean theorem calculator. That all works out for you. But for right now, we should use a trig ratio. So either sine, cosine, or tangent. It honestly does not matter. I think that the example we just saw online, they just use this information right here. So what you need is a one angle, okay, either 28 or 62, and then you need to use one of the side lengths you know. And you can use that to solve for one of the side lengths you don't know. All right, and there's a few ways you can do this, but we're just going to go ahead and use these three pieces here. So I know the angle, I know one side length, but I'm missing the other side length. Okay, so that's the conditions. You have to have the angle, have one side length or the hypotenuse, and you're trying to solve for an unknown side. Okay, we could have chose A, could have chose C. Either one will work. Just pick one, don't do both, won't help you. And the same thing, we could have chosen 62, but I just chose this because it's all close together. All right, so according to 28, if this is my angle, this would be my opposite, this would be my adjacent, and this would be my hypotenuse. So remember SOHCAHTOA. If I have an angle of 28 and I have the adjacent and the hypotenuse, right, where I have the adjacent, I'm looking to solve the hypotenuse, just those pieces of information there, I should use cosine, because cosine, it says adjacent and hypotenuse. Okay, so I'm going to use the cosine, I'm going to use this one here, the cosine of A, which is 28 degrees, is equal to the adjacent divided by hypotenuse. So 7 divided by C. Now, I know this might look kind of weird. You're like, I just don't know what to do with any of this kind of stuff. Cosine of 28 is simply just a number. Okay, what I mean by that is you can use a calculator to calculate that number. Like, what is the cosine of 28? So a few things to be mindful for. Okay, your calculator you're using should have these functions, the sine, cosine, tangent functions. It'll just say, sin, cos, tan. So we're going to use the cosine button, type in the number. Now there's calculators online. Just make sure that it's in the right mode. Okay, this calculator is hard to see. It's got like a letter D there, and there's other modes to do. Like it's called radian mode. We could have put it in radian mode. It makes a little R right there. And if I do the same thing, it's going to give me a different answer. It's like a negative number, like what the heck? All right, so just make sure you are working in degrees and not radians. Radians are a different way to measure angles, and we're not there yet. So as the online video had mentioned, 4 decimal places is very common with these functions, okay? So I'm going to write 0.8829 in place of cosine of 28. So what's so cool about that cosine of 28 is this fraction, when we divide it, needs to equal 0.8829. That's just how it works out. That's how every cosine of 28, whenever you have the fraction that's created, the adjacent divided by hypotenuse, that fraction will divide to that number every time. Okay, that's the cool stuff you can do with trigonometry. Okay, so at this point, you have 0.8829 equals 7 divided by a variable, or we call c for our hypotenuse. If you're not strong at this, you can use an algebra calculator. Okay, there's a lot of websites you can use. I think one I've been recommending for students is mathpapa.com, I think, or .net. Let me double check. I might give you guys the wrong website. Yeah, it's the Algebra Helper. Okay, so if algebra is a weak spot for you, use a website like mathpapa.com or something similar, and that can help you out through this process. Just this equals that divided by that, and it'll give you your answer. But we're going to do the long way of algebra. We're going to multiply both sides by c. Okay, so what we get is 0.8829 times c. So just put the c afterwards, and that equals. So we multiply both sides by the denominator. It gets rid of it, and all we're left with is just the 7. So now we're going to divide both sides by 0.8829. 0.8829. And that will cancel, cancel, cancel. So what's left on the left side is just c, and what's left on the right side is going to be 7 divided by 0.8829. And we get 7.928. Let's just write all that out, and we'll kind of see if we have to do problems later. We can cut that off. At this point, usually with side lengths, we kind of just cut it off after the first decimal spot. So the sine, cosine, tangent, we'll do 4 decimal places, but if it's just a side length, let's just kind of think about just the 1 decimal place for now. We'll keep it like that. So I have C, which we're going to call 7.9. Someone's got a question. Clara says, internet slow. That's fine, Clara. I'm recording this lesson, so if you have issues, because this is a pretty complex topic, you can always review this video. I'll post it a little bit later. Okay. So if we have 7.9 and 7, we got to solve now for our side length. So we have a few options. We could use a trig ratio again, which is one of my favorite things to do. But I would say grab a calculator and let's do Pythagorean theorem. You're like, why are we doing Pythagorean theorem? Well, Pythagorean theorem is great when you have your 3 pieces, okay, like your sides A, B, and C, and you know 2 of them. Okay, you're just missing 1 piece. If you have a triangle and you're only missing 1 piece here, Pythagorean theorem is going to be your best friend. So that way we don't got to think about sine, cosine, tangent anymore. We can just simply say Pythagorean theorem. And we can say a squared plus our b squared, which is 7. So 7 squared. And that's going to equal 7.9. But that is being squared. So 7 times 7 is 49. A squared, still a squared. Now 7.9 squared is equal to 62.41. So using our algebra, and once again, there's a lot of online tools to help you guys out through this process if you are confused on the algebra. Okay, do not let the algebra make this difficult, because you can just use some help with a calculator or a website that will do a lot of these little mechanics for you. Okay, so I'm almost done. I have a is equal to 13, sorry, a squared is equal to 13.41, but that's not what a is, that's what a squared is. That's if we took our number and multiplied it itself. Instead of figure that out, they said to do the square root. Now this square root is going to be a gnarly looking weird number. So the square root of 13.41, that gives us 3.6619, so on and so forth. Let's just round this up to 3.7. Okay. So once again, for the side lengths, you can kind of keep it like this with just one decimal place, at least one decimal place, I'd say one or two. But with the sine, cosine, tangent, angles, these decimals, it's highly recommended that you do the 4 spaces. Okay, so when you convert the sine, cosine, or tangent angle to a number, 4 decimal places, but everything else you can just kind of keep it like, as small as possible. Not, let's say as small as possible, but you don't got to be too exact with it. Okay, so we have our A value, we have our C value, and we have our angle. So we have all 3 sides and all 3 angles. Okay. All right, I'll stop this video and I'm sure I'll be making another one for another example.